We're looking at homework for section 9.1. This is question number 11. The accompanying table shows the height in inches of 8 high school girls and their scores on an IQ test. Complete parts A through D below. Part A, display the data in a scatter plot. Choose the correct graph below. So, when we look at these graphs, the x-axis should have values in the 50s and 60s. So that immediately eliminates graph A, which has its x-axis from 90 to 140, and B, which also has its axis from 90 to 140. So now we're down to choices C and D. What we notice is that there's one point that is remarkably different between the two. This point is a major difference between the two graphs. So let's check to see if that point is on our table. That point looks like it's about, let's see, this is 52, 54, 56, so this is 55 and a little bit more than 130. Do we see that point on our table? And yes, we do. It's 55, 131. So since that point is on the graph for C, but not on the graph for D, that's going to eliminate choice D for us, which means our answer here is choice C. So that's part A. For part B, calculate the sample correlation coefficient, which is R. We're going to build a table where we have the x's in our first row and the y's in our second row, and I've added in rows for x times y, for x squared, and for y squared. So first, 62 times 112, x times y, is 6944. 57 times 106 is 6042. 65 times 109 is 7085. 66 times 117 is 7722. 57 times 100 is 5700. 62 times 112 is 6944. 65 times 118 is 7670. And 55 times 131 is 7205. Then I square my x's. 62 squared is 3844. 57 squared is 3249. 65 squared is 4225. 66 squared is 4356. 57 squared is 3249. 62 squared is 3844. 65 squared is 4225. And 55 squared is 3025. Now we square all the y values. 112 squared is 12,544. 106 squared is 11,236. 109 squared is 11,881. 117 squared is 13,689. 100 squared is 10,000. 112 squared is 12,544. 118 squared is 13,924. And 131 squared is 17,161. Now we add up each of the rows. When we add up all the x values, we get 489. When we add up all the y values, we get 905. When we add up all the x times y values, we get 55,312. When we add up all the x squared values, we get 30,017. And when we add up all the y squared values, we get 102,979. Now, you may be wondering why I chose to do it with the table instead of on the calculator. And the answer is not everybody has access to those TI-83 and 84 graphing calculators that do the correlation coefficient for us. So I felt like I needed to show the actual method that you would do to solve it if you didn't have one of those cool calculators with all the built-in functions. So now we're going to take those values, those row sums, and we'll keep them up there at the top, and then we'll do the calculation for the correlation coefficient. R equals n times the sum of the x times y's minus the sum of the x's times the sum of the y's over 2 square roots. The first square root is the square root of n times the sum of x squareds minus the sum of the x's squared. And the second square root is n times the sum of y squareds minus the sum of the y's squared. So we have each one of these values. Remember, n is the number of data points, and the number of data points here is 8. So we get 8 times 55,312 minus 489 times 905 over the square root of 8 times 30,017 minus 489 squared times the square root of 8 times 102,979 minus 905 squared. There are 6 multiplications to do. So 8 times 55,312 is 442,496. 489 times 905 is 442,545. 8 times 30,017 is 240,136. 489 squared is 239,121. 8 times 102,979 is 823,832. And 905 squared is 819,025. Now that we've done our 6 multiplications, there are 3 subtractions to do. 442,496 minus 442,545 is equal to negative 49. 240,136 minus 239,121 is 1,015. 823,832 minus 819,025 is 4,807. So now we plug that into our calculator, and we get negative 0.0221832921. So R, we round that to 3 decimals, is negative 0.022. So based on that correlation coefficient, we want to describe the type of correlation we have. That value is very close to 0. And if you remember from our description, when the correlation coefficient has a value close to 0, there is no linear correlation. Now, we want to be able to describe what's going on here, and the answer here is choice B. Based on the correlation, there does not appear to be a linear relationship between high school girls' heights and their IQ scores. So some people might say F sounds right. Based on the correlation, there does not appear to be any relationship between high school girls' heights and their IQ scores. But when we're finding R, we're looking for a linear relationship, not just any relationship. It could be that there's some nonlinear relationship like a parabola or a cubic graph that explains these things. But that's not what the correlation coefficient R finds. It finds the strength of a linear correlation. So that's why it's choice B and not choice F. Lastly, use the table of critical values for the Pearson correlation coefficient to make a conclusion about the correlation coefficient. Let alpha equals 0.01. So let's bring in that Pearson correlation coefficient table. And we're supposed to find the critical value. Now that's dependent on our level of alpha as well as the size of our sample. There were 8 data values in our sample, so we're looking for n equals 8 and alpha equals 0.01, which gives us a correlation coefficient of 0.834 off the table. So then we compare the critical value to the absolute value of the correlation coefficient, and we find out that this critical value is much larger than the absolute value of the correlation coefficient. Therefore, there is not sufficient evidence at the alpha equals 1% level of significance to conclude that there is a significant correlation between high school girls' heights and their IQ scores. And that's your answer.